Alright. Alright, hey listen, make sure you got this. You need your folders and a sheet of notebook paper. The notebook paper needs to come out. Yes, ma'am, you sure can. Okay, so what we're doing, what should be at the top of your notebook paper?
Name and period.
Period, very good. Okay, and so what we're doing today, we're getting ready to rock and roll on air movement. How does air move? All of the above, okay? And so your scenario, let me pull it up here on the board. This is your bell work. You're going to have 5 minutes to do this, okay? Here we go. All right. You are... Guys, listen up. Okay. I want y'all to picture this. I want y'all to picture this, okay? Hey, Pruitt, why don't you wait until I get to explain this and you can, okay? Yes. Okay. So listen up. In about 3 weeks, you guys are gonna. In about 3 weeks, you're really going to experience this on a whole different level. 1 second, Kenji, I'll get you. Okay. It's going to heat up to about 80 to 90 degrees in about 3 weeks, right? Because that's just how Arkansas rolls. Okay? So I want y'all to picture it. It's about 90 degrees outside. Y'all are outside at recess. It's nice and hot. You come into this building, we got the air conditioner rocking, right? So you open that door, what happens to the air? Okay. So that cold air blasts you right in the face, right? Does the hot air go past you into the building?
No.
All right, so what I want y'all to do, I want you to draw a model of what happens when you open that door and that cold air blasts you in the face, okay? I want you to label, if you're drawing arrows, I want you to label what's the cold air, I want you to label what's the hot air, okay? All right? You got 5 minutes. What? Yeah, bring it up here.
Maybe use the whole page, right?
Yeah, you can use the whole page.
Yeah, right.
Okay, this is for drawing.
Awesome. Awesome. So she's in the back here. Where is he not here today? He's not here today? Okay. All right. We'll keep it up, and at 10, when this clock up here says 10:28, we're going to put our pencils down and we're going to talk about it, okay? All right. Looks like Ethan's the only one that we're actually missing today, correct? You look at me, please.
size?
Air is invisible.
Yeah.
No, guys.
Will be there, but it's invisible.
She's doing squiggles. Squiggles are good. Not like
Okay, y'all look up here. Okay. So it's you can fill this out as we're working. Okay. So it's like 100 degrees outside, right? Okay. I'm gonna use a model of what somebody drew in second period. Okay. So we have our little schoolhouse here. It rocks. That was awesome.
yeah, it
Schoolhouse rocks. Has anybody seen Schoolhouse Rock?
Yes.
I know I'm old, but I'm not that old.
No, I know.
Alright, so it's 100 degrees outside, okay? Okay? And inside our schoolhouse, it's 68 degrees, okay? Now I'm tired of being hot, I'm ready for lunch. Mr. Staggs blows the whistle. We line up and he opens the door. I'm at the front of the line because I'm good. I'm awesome, okay? I open that door. What is going to hit me in the face?
Hold air.
Cold air. And I go feel it's going to be like, oh, that's awesome. And then what happens? The hot air kind of, some of it comes in, but is the volume as much? Okay. Yeah, but that hot air is going to kind of go in too. Okay? All right. So, we know that air is constantly moving, right? We know that, right? The particles are constantly moving, right? Yes?
Yeah.
No, Mr. Carroll, I have no clue what you're talking about. Okay? So we know that air is constantly moving, but what do we call that? What do we call moving air?
Circulation.
When we're outside, what do we call moving air? Wind. We call it wind. We call it wind. You windbags? Right? Okay, so here's the deal. But why does it constantly move, right? We need to figure that out. And wind is constantly moving, guys. Over here. Yes, yes, ma'am, absolutely. So Princeton and I were talking earlier about his drawing, and we talked about why is that air moving out? And Brooklyn asked me about, you know, when she goes in and that hot air rushes past her and the cold air comes out. And we know that tornadoes happen when hot air and cold air interact. Why doesn't that cause something? Okay? Well, we're talking about a much smaller scale. But here's something that you've got to understand, okay? Air is always going to move according to pressures, okay? I gotta click. Okay, so what we're going to do, air is always moving. So you guys just did this, okay, from an area of high pressure to an area of low pressure. Yes, ma'am. If you want to, I would suggest you keep up with it a little bit. Yes. Okay, so how much is this? Is the air that's in this balloon right now high pressure or low pressure? Low pressure. Okay. But Mr. Carroll is full of hot air. Okay.
High.
Hotter.
High. Stop. High.
Now, is this high pressure or low pressure? High, right? It's got more pressure in here than the outside air, right? So which way is the air going to move?
Out.
That way.
Towards you guys, right?
Yeah. Go that way.
Roll.
Go that way.
Oh gosh. Giving.
Let it go. You should let it go.
And there it goes. Right? Okay, so that was an example. Yes.
Okay.
Yes, that is me after Taco Bell. Okay? It is high pressure moving to low pressure, right? Just like if I were to air this up
Mr. Carroll.
and I let it go, yeah, and I would let it go, that air is going to move it, right? Okay? All right. The difference is in air pressure cause the air to flow. Okay? Wind is that movement. Okay? All right. So, we're going to watch a short video on how this happens. What causes breezes? What causes wind? Did you guys know there's two different types of winds?
Yes.
There's local winds and global winds.
Global ones are all around.
Yeah, so the global winds, they're constantly moving. Okay? They're constantly moving. And then we have our local winds, and how many of y'all know during the summer you kind of hope for some pretty good wind. But during the spring you're like, it's a little too windy. Okay? That's all influenced, and it influenced, the local winds are influenced by global winds. Yes, Kristen?
It's like when you're outside, like you're running a lot, and like it's really hot outside. They just be still with the wind.
And you really want that breeze, right? I can remember in college, I was helping to frame, I worked for a construction crew and we framed houses. And I'd be up on, we were building a house up on Blackberry. If you go out, Donaghy, you keep going, or, yeah. And you keep going out South Donaghy out towards Round Mountain. We were building a house back there. And I can remember it was like 102 degrees. And I was like, man, and it was no wind. It was just stifling. That's when you really, really wish it'd be windy, right? Now, if it's 20 degrees outside, do you want it to be windy?
You want it to be hot.
You want that sun to come out, right? Okay, so you guys are pretty good on the understanding how local winds are different than global winds, okay? But let's watch this video, okay? We're going to talk about all this. Now look up here, okay? Oop, I got to unmute it. Sorry. Let me start it over.
It's a sunny day at the beach. As the sun rises, the land warms up faster than the water does. This causes the air above the land to also warm up. Warm air, being less dense, expands and rises, leaving an area of low pressure. Meanwhile, the air over the ocean is cooler. Cooler, denser air sinks over the water, creating an area of high pressure. The differences in pressure and air temperature create a convection current. Warm air over the land is replaced by cool ocean air. This air is warmed by the land and rises, and the cycle continues. Winds that blow from the sea to the land are called sea breezes. At night, the convection current reverses. After the sun has set, the land cools more quickly than the water. Therefore, the air above the land also cools down. Cool air, being more dense, presses down over the land, creating an area of high pressure. Meanwhile, because water cools down slowly, the air over the ocean is still warm. Warm air, being less dense, expands and rises, leaving an area of low pressure over the water. At night, cool air over land moves towards lower pressure over the ocean. This air is warmed by the water and rises, and the cycle continues. Winds that blow from the land to the sea are called land breezes.
All right. Okay, so if it's blowing from the land out to the sea, what's that called?
Ocean breeze.
No. If it's blowing from the land.
Oh, land breeze.
Yeah, land breezes. If it's blowing from the sea.
Sea breezes.
Sea breezes, yeah. So one of the things, y'all see how that works, right?
Yeah.
So how does the sand get warmed up? What thermal energy transfer is occurring with the sand? Radiation, yeah. And so when the sand heats the air up, what's happening?
That's going to be conduction.
Conduction, because it's in contact with it, okay? And then, when it starts moving, that is convection, yeah, convection. Vect vection means to carry, okay? And then convection is just carrying that heat around, okay? That's how that works. But let's talk about some more things, okay? The sun's energy warms the earth unevenly. We know that, right? We talked about that with that activity we did a week or so ago, right? We know that hot air rises, okay? Because it's less dense. But let's talk about this. How many of y'all have a bunk bed?
I used to.
I used to.
Who gets the, do you get the top bunk?
I have
I
one.
just have a top.
Okay, how many of you have to share a bunk bed with a sibling or, okay? Who's got the top bunk?
Me.
You?
Younger.
Okay, the younger one gets the top bunk?
Higher.
Okay? You know what I used to do?
I didn't tell her.
So, listen.
Oh, I almost had a 3 bump.
Alright. Back up here. Back up here. Okay? Listen. No, I'm giving you this minute. I know. Okay? So if you got the top bunk, or if you're like me and you had the bottom bunk, because I was the oldest, so I had to sleep on the bottom bunk, but I was a little jelly because I wanted the top bunk. You know what I do to pay my brother back?
Kick him.
Yeah, you know you didn't.
I mean, I crack them off and I let that hot air float up to him and he'd have to smell it because he ain't going nowhere. Alright? Because hot air rises. Okay? And cold air sinks down. Right? Okay? Yes, Elise.
That's why I have. So my whole life I've actually had a bunk bed, and I used to share with my siblings. And how me and my siblings would communicate, we would make like a plastic tube and we would like talk. And now since I'm older, I have it to myself.
Okay. Well, there you go. My son has a loft bed by himself. I'm like, don't fart up there because you're trapped in it.
Yeah.
But here's the deal. Yes, Kennedy.
Is that when you're in a sauna, like maybe on the floor, older?
Yeah. So another thing is that's another reason. Hey, let's talk about this. She said that's why if you're in a sauna and you get towards the floor, it's colder. Here's another thing. If you're in a house fire and the smoke is rising, what's the best thing to do?
Drop.
Get on the floor and crawl out, right? Because all that hot air is going to rise up. Very good observation. Okay, hang on.
It's on fire, it stops, drop it.
These differences in pressure, though, create the cycle. Okay, so we got high and low. Okay? We talk about weather systems with high pressure and low pressure. Let's see if I can do this without popping. All right? High pressure, low pressure.
Papa, you won't.
Oh, not good.
You pop at the influx.
Shake the.
Oh, that's the equator.
Yeah.
No, the world is a rectangular circle.
So what I'm doing here is we're going to discuss how many of you know that the earth, the wind on our earth is not. Our wind does not blow in a straight line. Did y'all know that?
Yeah.
Okay. Right. So we're going to look at this and we're going to talk about how does this affect it. Is it on topic? Yeah. What you got?
If I was north, south, or west, what do you think I'd be?
That is not on topic. We'll talk about that later. Come give me a recess and I'll answer that, okay? All right. Now we're talking about weather though, okay? So look. Yes, go ahead. So what we got here, and I'm gonna get a volunteer here in a minute. Okay, I've already got Brooke can do it.
My hand was up
But
though.
I'll tell you in a minute. Okay? So look, listen up guys. So by the nature of the smaller scale where we talk about those local sea breezes and land breezes, right, Kristen? When we're talking about those local breezes, sea breezes and land breezes, what's happening? That warm air is rising, and when it's rising, that cold air is going to fill into that spot, right? Because it's left a void. So that's happening. Well, where's the coldest air in the world?
The atmosphere.
Antarctic.
The Arctic, the poles. Yeah, the South Pole, right? Well, where's the warmest air?
Australia.
Don't flirt. The equator. Ecuador. Equator, okay? I'm not answering questions just yet, okay? Write it down. If you've got a question, write it down. We'll come back. We'll write it down. We'll come back, okay? Question statements or anything like that, we'll come back to, okay? However, so I want y'all to think about this, okay? The North Pole, coldest air. Equator, warmest air. What's going to happen to the equator air?
It's gone.
It'll go up, right? What's going to happen to the polar air? Polar air.
Down.
It'll come down. And that cooler air is going to cause that to occur. But it's not going all the way down from the bottom to the top, is it? Let's do this. All right, Brooklyn, come here. Oh, before we do that, did you want to pass out or do you want to do this?
It's my turn to pass out.
Oh, yes.
Demi.
Demi, pass these out, please.
No, you're supposed to go behind those and it helps all straight. But you didn't.
Exact same thing.
Mr. Carroll, you don't have any air in.
I'm connected though, we're good. Okay, so here's what's happening. Demi is passing out our worksheet for
The
this.
equator's not even.
It's alright.
It's wonky.
It's okay. So Demi is passing out, right now she's passing out our worksheet for this activity. For us to get to the next part, we gotta do this. Now guys, let's talk about something real quick. On your learning ladders, those learning ladders, we have for, I think it is -5 or is it -6?
It's both.
I'm talking about air masses. So -5. If you looked at -5, hey guys, there's a lot of talk going on. It needs to be focused up here. Okay? Y'all don't normally talk this much. Not to each other. Okay? Y'all better than this. Now look. Folder notebook, we've done that. Now let's look at our I can statement. I can statement for the ES-5, that is this part of our unit. You should be able to provide evidence for how the motions in complex interactions with air masses results in changes in weather conditions, okay? To get to that point though, we got to understand how is the air moving? What's causing it to move and why does it move the way that it moves? The first thing that we've got to figure out is how is it moving across the earth? So what we're going to do today is we're going to talk about this. We're going to fill this worksheet out as we do this demonstration, okay? All right, Brooklyn, come on up here. Brooklyn's going to help me with this demonstration. Okay? So, grab this. Okay? So what she's doing is this marker is going to represent our wind. Okay? I've got my North Pole, South Pole, and the equator. Let me go put a little E right there. Equator. Okay? My equator. Okay? Hold that. So what I'm going to do is she's going to put her pen here. Put the marker. Just wait. And I'm going to turn this. So she's going to try in just a minute. Okay? She's going to try to draw a straight line down. I want everybody needs to pay attention to this. Okay? All right. Let's go. Ready? Go. All right. Okay. Now, same thing. Up here at the top. Okay. All right. Good. Okay. So look here. Okay. Grab a seat.
Great.
So look here. The northern. Okay. So
Where is Bo?
he's at home. It was 30 degrees. I wasn't getting him out today. All right. When we're up here at the North Pole, which way does it look like the wind is going?
Right.
From right to left, right? Yeah, or to the right? Okay. So when we're on the South Pole, which way is it going? Is it going the same direction?
Yeah.
Yeah. It's going opposite direction. So you have 4 questions on your paper. First off, what should be at the top of every paper? Name and period. All right. So you have on this paper. We'll come back to this, but we're going to get to here first, okay? So listen, guys, look here. Okay? All right. Listen up, guys. Okay, we ready? Okay, we got everybody's attention? Okay, so in your first blank box, there's a box that's not got anything in it. It's right here, see? I want you to draw the balloon, okay? And I want you to label it north, south, and the equator. One line for the equator, okay? Draw that balloon, north-south equator. Yes, ma'am. No, I didn't have any red balloons.
Is it for your?
Yeah. All right, the equator. Okay, yeah. Yes, ma'am. Huh? So number 3 is going to be what happens. Okay? Yeah, it curves down. Okay? It curves down. Second period got assigned seats. Huh? I said this class was not going to get them just yet. That's not okay. All right. Okay, what happens in the northern hemisphere? What happens in the northern hemisphere when we draw a line from the North Pole to the equator? What happens?
It curved down.
Which direction?
Down.
To the right, right? Okay. Write that down.
Where? Right. Wait. For number 3. Number 3
Yeah, and to the right. It curves and goes to the right, remember? On. Well, I'm about to shut down the bathroom.
Wait. Y'all water that messed up?
It's like 7 persons. Okay. Okay. So, how is the southern hemisphere different? Pruitt?
The wind is going the other way.
It's going the opposite direction, right? It's going to the left. Yeah. How many of y'all caught that? What I just said.
The ball?
So, yes. How is the southern hemisphere different than the northern hemisphere with the wind? Yeah, Tyler.
It's going to curve up, and that's going to end up contradicting each other whenever they pick up.
Yeah, if they meet, yeah, we're gonna have problems. Okay, how many of you guys knew almost every hurricane we get in the Gulf? I'm saying if we get them, how many of y'all knew that those storms originate off the coast of Africa? Did y'all know that?
No.
Okay, and if we were to trace the winds, up, if we were to trace the winds up, you can kind of almost see this same pattern, okay, and how they flow up along that boundary, okay? So let's look at this next thing, okay? Your next set of questions 4 and 5, will be answered here, okay? So the Earth's what causes moving air and water to appear to curve to the right?
Rotation.
It's rotation. The Earth's rotation causes moving air and water to appear as if it is moving to the right. Please, guys, if it's in red up here on the board, you should probably be writing it down in blanks. Pro tip, just for grade.
Oh.
Remember, I don't give you all worksheets
Even
just to have
better.
y'all do worksheets. They're always for a grade. It's always for a purpose.
What? Can you say it again?
It's up here. The Earth's rotation causes moving air and to make it look like it's moving to the right. Moving air and water appears to curve to the right. Okay? So we'll talk about this in just a minute, because this is actually something that's really, really cool. Yes, sir. In just a minute. And then that will be in the northern hemisphere. If it's moving to the right, it's the northern hemisphere. And then it makes it appear to move to the left in the southern hemisphere. Okay? The Earth's rotation is causing the moving air and water to appear to curve to the right in the northern hemisphere and to the left in the southern hemisphere. We got that? Okay. This is known, we call this the Coriolis effect. Okay? The Coriolis effect. Coriolis effect. Coriolis effect. Okay? This causes the curving patterns of circulating winds. If you look, this last week, how many of y'all have ever noticed? Most storm systems don't go just straight east to west, do they? Or west to east. They don't go west to east. Which way do they normally travel?
East to west.
Nope.
Everywhere.
They'll, most of the time they're either going north from southwest to northeast, or sometimes you might get them where they're moving from northwest to southeast, but they're almost always going left to right on the map, right? And they almost always kind of have a arch as they're going up, correct? Okay? That's because of the Coriolis effect, okay? And we're going to look at a picture here in a minute of this past week since it's really relevant for us, okay? Here's another thing, okay? Next section. Land masses. Land masses are another thing that will affect wind, okay? And what this does is land mass can affect the speed and direction of a wind system. Yes, Mia?
Mr. Carroll, your head is in the way.
I'm sorry. Yeah. Land masses affect the speed and direction. The speed and direction of a wind system. For example, the westerlies in the southern hemisphere are locally very strong because this system is mostly over the ocean. Which direction do you think the westerlies are traveling? Right? And when wind meets a mountain range, it is deflected and forced up into the upper atmosphere as shown in this picture. Okay?
Is that why it's colder in the I thought it was supposed to be space.
Have you ever been for like a holiday and then it snowed like as soon as you left the
Yes. Yes, I
You
have.
could have gotten in the mountains of California.
Okay. Do we have the blanks? Do we have our blanks? I'll hold a space. 0 degrees for 100% absolute security. We'll look it up. I don't know exactly. Oh, yeah. It's a vacuum. All right, guys. Questions 6 and 7. You will find your answers. 6, 7. All right, you will find your answers in yellow up here. Okay, you guys? Now, let me ask you something. This weekend, how many of you guys were watching the weather Friday night? Okay, let's bring it back in. 5, big RD. RD? Okay, so, I'm going to show you guys something here in a minute. This weekend, one of the things that happened is that system just kind of set up over Arkansas, and it went all the way from south, like northeast Texas, all the way up into the Ohio Valley.
Wait.
Yeah, it stretched all the way up into the Ohio, like basically spanned the whole United States,
Yeah,
south to north. Okay, guys, I've got a question for you. Just teach it. So why do I hear?
Because people are not.
Not very skibbity of y'all. Alright? Alright. So listen, guys. On Friday, what we had last week, starting on Friday the 28th. Yes. On Friday the 28th through yesterday, we had a historic event. Yes, Peyton. Yeah. The storm system spanned all the way from Texas to Ohio River Valley. Okay? Okay? It was a massive system. It was historic. It doesn't have to be sharp enough to poke your eye out. Okay, hey guys. Look, what are we doing?
We're supposed to be listening. Just your lips and listen.
Thank you, Bree. Okay, so look. Do it. So look. What was going on with this though is we had the winds and everything was there. Okay? But what was happening is, remember me talking about that pressure? We were very, very fortunate. On Friday, all of those storms that generated tornadoes, we had very few actually put a tornado on the ground on Friday. Now, Wednesday was a different story. If it went tornado warned, it pretty well dropped a tornado, right? And we couldn't figure, like some of y'all were asking me later in the day on Friday, why did that not happen? What was going on? Well, our wind speeds, the wind was affected. And so the energy kind of was getting sucked out of that atmosphere. And so the convection could not occur to get that spin and cause them to spin up. Friday night, there was a line. I'll draw both parts, okay? So there was a line across the state. So we'll draw our state here for us. Okay? And this is how wind affects weather. Okay? We had that forecast. We had that predictability, right? We were able to predict what was going to happen with our forecast, correct?
Yes.
Yeah? Okay? So Conway's right here. Okay?
Yeah.
And we had a line that was coming up and it curved like that. Okay? That's,
So good.
and then I'm going to erase portions of it so you can kind of see this. So then you have your low pressure. This is a frontal boundary. Okay? What this is this is where that cold front, over here, we were at 81 degrees. Okay? That was the temperature here. Okay? We were at 81 degrees. North of it, it was 50 and below on Friday. Okay? How many of y'all realize it was 40-something degrees Saturday? And it was 40-something degrees yesterday, right?
That was cold.
It was cold.
It was
It was cold. It was a lot colder than it was on Friday, right? This cold front was coming through. But what happened is when it got here, that wind energy kind of stalled out. Okay? We didn't have those winds interacting like normal. Okay? And so that wind had an immediate change on that weather. Now, all that moisture, all that storm energy was still there in the upper atmosphere, but the wind wasn't moving it quite like it needed to. Okay? And so what happened is if it went tornado warned on this side of the boundary, it usually dropped something, or it could have. It was much more dangerous. On Friday, how many of y'all know every single tornado warning happened either on this boundary or south of it? Did y'all know that?
Yeah.
Every single tornado warning on Friday was south of this boundary.
There was supposedly a tornado on Saturday on Highway 65. There was.
Saturday there was not.
5.
Okay, not here. In South Arkansas, Highway 65 down around Pine Bluff there was. Okay, so that's down around here though. 65 runs.
Yeah, but they turned
Isn't it
all
Pine Bluff and Los
They turned-
Angeles?
What?
That's what I saw on
They turned our is not.
Friday. Friday they did. Okay. Anyways, the wind energy energy made a direct. The wind energy had a direct impact on what happened with this storm. Okay? Now the winds pushed these frontal boundaries through. Okay? Now, let's go back. Brenda, what's your question, bro? Yeah, but where you were.
We went and we had to go into the bathroom. During my
So you weren't, but you were in Tennessee.
During, yes.
Okay. So now listen, guys, hang on. I want y'all to hear this, okay? So one of the things, once upon a time, somebody asked, why did the storm that produced the tornado that hit Bologna, that basically wiped it out, what caused it to be so strong? So this is where this is important. Land mass. The land masses, as it came in, and this is why it took the same path. There's a place just outside of Moore, Oklahoma, that 12 different tornadoes have gone over that exact spot within like 100 yards. Okay? That's crazy, right?
Yes.
Geography, like land mass, makes a difference. So in Arkansas, when that tornado came through from Mayflower to Volognia, both times, when it was an EF2, right around 2009-ish, 2010, 2009 I think. In 2009 it was an EF2. Just 2 years later, in 2011, we watched that video, right? Okay. In 2011, that tornado was an EF4 this time. Could have been an EF5, really. But when it came in, it followed the same path in less than a mile of accuracy. And so when it did that, the winds was pushing the tornado towards the hills. It went up the hill and it kind of died down a little bit, and then it deflected back down this mountainside out past Lake Conway. When it came down that mountainside, it gained speed, because that still can happen, right? How many of y'all knew that wind speeds can increase as they're coming off the backside of the mountain? Did y'all know that?
No.
To us, we just think of, if I set a ball at the top and roll it down, it's going to pick up speed, right?
Yeah.
But winds pick up speed coming down the
It's
mountains
the
as
same
well.
as, like, if you put like a car and move it in like where it
Neutral.
moves,
Yeah.
it will shoot.
Yeah, it'll shoot down.
But
The wind will do that too. Land mass, air temperature, and the rotation of the earth all affect the direction of the wind. Tyler.
The way that you can actually see that in real time is around Mount Vesuvius.
Yep.
Especially during Pompeii.
Yep. So you can see this with the pyroclastic flows as they come off the side of volcanoes. That's just hot air that's just superheated hot air that's being blasted down this mountain, right? Okay, that's just, most of it's air. Now it does have ash and stuff with it, but we can see that. You can also see that if you go to Colorado, and if you're a pilot, which one of my really good friends is a pilot, he flies for American Airlines, and he talks about, y'all know where the most dangerous places to fly an airplane
The
is?
triangular the thing.
Not Bermuda Triangle, no.
This guy, there's a tornado.
No, coming over Colorado Rockies, there's a section just outside of Nevada. As you're coming down through the Continental Divide, the air that comes over the Rockies is extremely turbulent, because it's being shot up the backside on the California side. It's being shot up that, and then it's coming